Thanks for having me. My name is Chewa Choi. I'm from George Washington University in Washington, D.C., United States. Today's topic I want to talk about is AI in education because I'm not expert in AI per se. I'm rather expert in something else very similar in terms of, acronym AIG, which we say automatic item generation. But there's some relationship between the AI and automatic item generation, and I want to share my thoughts and insight related to my work as a psychometrician. All right, challenges and opportunities. Challenges: digital transformation everywhere, right? And it's not just limited to education, and it's everywhere. And just depends on different sectors. I understand, but we can get rid of this digital transformation nowadays because we're transforming money to digitally, and we're transforming our procedure to digitally, and we are transforming our meetings like this type of meetings and digitally. So lots of things transform into digital setting. But how about education, right? Education sector is the main characteristic of education sector as it is some kind of in between public, private, and non-private. You know, so and then not only our service and goods and services in Korean 재화 or other things, it's very hard to evaluate as other sector using a price tag, right? And that's one of the biggest characteristic, and it works as I think it works as a challenges in education AI. Let me tell you why. The reason is instead of the we are full customer and the we sort of like a semi profit sector or quasi profit sector, and educational big educational technology company is compared to another sector technology company as too little, or they're saying the big tech companies saying, you know what, Jehua, education is too little as a market, we better developing something else than educational application because market is too small, as you know. And then and then also, and not every sector becomes plays major role as this AI education or digital transformation, but most of education people's works as a client or customer. So we have to wait until other people developing software and other people developing some kind of infrastructure for us, instead of the we become a creator, and instead of the we become a central role in digital transformation, even in education, right? So how many of you able to contribute to this digital transformation, right? And then we have to wait until someone else develops some kind of software and the material for us, right? That's challenge I identified. And then also education, and it is like we are educators, we are not technicians, we are not engineers, right? So not automatic automation, so artificial intelligence works as a concept words in education, and everybody started defining automatic item generation as a concept words because we can't touch AI. I mean, we were using some services, but we don't know what's going on in AI because our technicality is not there because we are dependent on technicians, engineers, and doing something for us, right? And then we can even easily describe what the AI is. So I just want to describe this kind of situation as the blind man and the elephant. Some people said AI as a big trunk. Some people said AI as big ears, right? Big legs, right? But everybody talks about a type of elephant, but we don't know the elephant, right? If we don't know elephant, how do we critically evaluate AI service, right? Products and contents, right? So that's the biggest challenges in education AI and based on my observation. That's the reason why the AI in education is very different from some other sector, frankly speaking. You know what? And they're using a Zoom and upload our file to website and cloud service and download, right? Do you think this is the technology we are talking about fourth industrial revolution? I heard this kind of technology in 20th century. I don't think this is a revolutionary and innovative technology at all. That even though we keep arguing, oh, using a Zoom, I upload my videos and upload my educational materials, students can download. What technology you're talking about it? What big data you're talking about it? Right? What big machine learning you are talking about it? Right? We are talking about big data, AI, machine learning at the level of the mass media and fifth grader in elementary school can just barely describe. We are expert. We want to understand much deeper than just mass media description about the AI, right? How knowledgeable we are about the AI. It's time to be, you know, faced with that kind of situation. So that's the challenges I can describe because we don't exactly know what the AI is, right? But the opportunity as a psychometrician, I'm proud educational researcher. I'm doing conventional psychometrics and I try to do my best to incorporating those digital technology into psychometric and evolving psychometric to more futuristic directions. So there are a couple of opportunity I can see it as educator, right? And I want to share with you how we becomes right instead of clients, and instead of some dependents, and then wait until someone else develop for us. Because danger, crisis in Chinese, 기회, is the same. I mean, the wiki is the same as opportunity as 기회 in Chinese as well, right? So we are using the same words in wiki and 기회, which is they're meeting each other. Crisis and opportunity had some commonality. And let's try to understand what that means in AI in education together. Because if we change our paradigm, we as educator, we as expert in teaching and education about the knowledge, and we are playing central role of knowledge transfer to from last generation to next generation, and then lots of things going on in this area. And I try to looking for the keywords and the describing, right, and this kind of phenomenon which is related to knowledge transfer, right, and will be enhanced, evolved because of technology, including cognitive science. I want to say yes, knowledge representation, knowledge modeling, knowledge engineering. See, we're supposed to be expert in dealing with knowledge, construct, right? We are modeler and psychometrician and one of the your Yun Jung Choi and one of the faculty member and doing in here, we are modeler. We are very expert to do dealing with, right, construct and assessing and measuring, right, and those kind of the construct, which is knowledge, right? But we are not as savvy as engineer in technology, but we are educators. We're supposed to be good at knowledge, right? So let's try to evolve what we are doing it as this knowledge engineering because we're expert, right? The whole idea of my suggestions or my proposal is not my proposal. It's a Dr. Miss Levy's proposal, which is evidence-centered design. Is let's build up a type of digital form of knowledge-based system. We call it a machine knowledge, and I want to call it as a digital knowledge, right? Let's use that digital knowledge when we transfer human knowledge from the last generation to next generation. So not only to teach next generation human, which is learners, through this analog learning environment, but also we able to accelerating the efficiency of teaching next generation and through this digital pathway, which is machine education, which is let's educate machine first based on our expert knowledge, and then let's utilize that educated machine, right, in helping next generation human, which is students, right? That's entire fundamental idea of this machine education for human learning paradigm I propose. This idea is very, very similar to other type of data-driven method, which is we are also expert, right? But this is generative algorithm, right? And the we machine, which is statistical method, if we have a large amount of data, and that we can generate these real people looking like type of pictures based on algorithm. We are copying top-down method of this generative algorithm, right? This is generative algorithm based on data-driven method. For example, artificial neural network, etc., etc. Let me explain and my understanding of AI and every effort to what we are doing it in this direction. The problem, we have to understand the problem to what we are doing, and we have to understand what kind of things we like to solve based on that reflection of the problem to what we are doing right now, right? The problem of what we are doing it, creating assessment and creating educational material and then teaching it, assessing it, analyzing it. We have a beautiful teachers are doing a fantastic job, and we have a less beautiful teacher doing a less fantastic job. The problem is we don't know who did a great job in writing item and writing assessment and teaching fantastic way or not fantastic way. Why? Because educational service, contents and service are analog. It's implicit. It's implicit. I know. Sometimes good, sometimes not good. We don't know why. The thing what we like to do it is every expert, right, and that we work together, make that implicit, right, procedure and behaviors of the conventional educational analog education, what we've done it to make it explicitly observable way through digital technology, right? Of course, we need to have engineers and working together, right? But if we using and if we building up this kind of new paradigm educational framework, right? And then the things going on inside of this world, it becomes much more visible. And then if there's something wrong, and then we can fix it. And it's going doing well, and then we can improve together. It starts from the item modeling, which is a form of creating assessment materials and assessment on tools based on model, right? And then the idea of the item model has been expanded to incorporating cognitive model or curriculum model, and it's much more standardized and much more a curriculum coherent version. And then we adding statistical model to calibrate those item generated by item models, right? And then it ready to very fine tune adaptive assessment ready. If we want to computerize this, and then we call it as a generative psychometric modeling, sometimes we call this automatic item generations, right? Based on theoretical framework, evidence centered design, right? But where that idea came from, where that knowledge came from, the when we are modeling this inside of task and item model, we can attach ontology model, which is another digital technology, and then we start to link this ontology model onto this item generation. Now we can call it as a knowledge-based generative psychometric modeling. Still, this is a psychometric modeling, right? But now we also attach learning progression model to monitoring and evaluation student learning, and that we also adding adaptive generation model to fully adaptively help student learning and assessment and in between. If we combine everything, I call it as a model chain, which is interactive model component and sequential data pipeline in digital form, right? Right. And then from here to here, we call it a rule-based deduction modeling. And from from to here is data-driven inductive modeling, because we will receive data from students and then we start to further optimizing the rule-based model and then we initially created, right? Let me explain the other way. Students, yes, they had implicit knowledge and we want to understand. And that's the reason why experts started figuring out, to understand what's going on for students, and that we developing assessment and other educational material to, teach them. But individual assessment items and educational material is like too little. So let's develop item model, right? And then generate item instances. Now we can support many students at the same time, right? But problem is that item model itself and the people need to develop, right? Handful of experts need to develop that item model, and that's also implicit process, and that's very, very subjective process as well. That's the reason why, right? And then we start to figuring out how are we creating generative model framework and using those item model. And instead of we directly developing item model from expert to teachers and assessment expert, and creating knowledge representations clearly to get ready to computer programmer can encode their knowledge representation to digitally machine friendly knowledge representation. And then we start to build up ontology model that related to what things we have to teach to students. And then that ontology model include the knowledge map. And then we are using that knowledge map and adapt to curriculum model. And then also adding pedagogy model, which is students teachers knowledge how to assess their weakness and strength, and how to identify those diagnosis process, and how to help students, and if we able to understand their weakness and strength, right? And then everything distilled into item model, and then we generate those item instances in digital native way, and then we able to handle those item instance, humongous amount of item instances in different type of learning content service layer services. And then we will receive data from students, because now all those item is implemented in different type of digital services, and then we start to further calibrating. And then calibration can be, if calibration finish and every information becomes very accurate, and then that adaptation becomes much more improved, and then we start to understand how student learning progress in later part, and how student learning progression information will provide another insight, and what kind of things we have to teach in next steps, and what kind of things we're able to help students, and then we further help students through build up the improved version of the digital knowledge. So we are circulating entire process, not only process but also data. This is the idea of machine education for human learning. Bitcoin, digital money, right? And digital knowledge. And then digital Bitcoin, blockchain technology, right? And through very, very interesting, you know, questions to us. What is money? We think we know what is money, but immediately and through this, Bitcoin type of blockchain, we start to think about what is definition of money and what is money and digital knowledge. And because we have to digitalize, human analog knowledge to digital way, and then we start to talk about knowledge. What is knowledge, right? So we have to understand the what techniques, this kind of, digital technology provide us as a solution for the digital scarcity. Think about this assessment, a list assessment, right? Once we provide assessment online, right, we faced into more danger because if once every assessment information and then we lose the security because if we implement assessment online. But this digital technology, which is digital knowledge technology with automatic item generation, basically solve that digital scarcity issue. Why? We don't have to worry about students are, play around our item anymore. Why? Too many. Too psychometrically valid and abundant number of items, and we don't have to worry about conventional test security and validity issue anymore. And digital contents as well. Now that based on that humongous amount of educational resources and practice problem, and actually we can harvest large amount of data. I want to call it that is a big data and that we're able to receive absolute knowledge as well. Hegel's absolute knowledge. If we keep continue to build up that digital knowledge and little bit over time, right? That digital knowledge is different from humans, and everybody need to die, right? But that digitally explicitly represented knowledge open network can evolve over time. So now that knowledge becomes better and better, and then we can call it as absolutely good one. And then we define as what? Really, really universally valid knowledge for mankind we able to develop together and maintain together using digital technology. I prepare a couple of references. I strongly recommend you this book because this is done by Dr. Miss Levy, and he described everything what I said in social cognitive foundation of educational measurement. We called it as evidence centered design. The digital knowledge is a form of digital form of evidence centered design from my perspective, right? All right, there are other references, and then you can check. And then I describe the same thing. Oh, recently I just finished today an 8-hour training related to automatic item generation for adaptive learning, and I got some Korean contents and teach this idea in 8 hours. Right. So if you are interested in, just let me know. I'm happy to share. Thank you.